mgh initial, then you can cancel mass, and then your v final is going to be just the square root of 2 times gh initial. So 2 times 10 for g, and h is 5, gives me again 10 meters per second. Let's say it's not a scared diver anymore, but a crazy elephant here. And since I don't know his mass, I don't have to guess. V initial is 5 meters per second, so he jumps. And it's worth noting that the direction of the jump does not matter, because in the formula mv squared over 2, v is squared. So whether it's negative, positive, does not matter, because it will square out. So you do initial energy equals final energy. Now notice that initial energy is now not only potential, because the elephant is on the board which is above the water, but also kinetic energy to add to it. So my mechanical energy initial is potential plus kinetic, and my mechanical energy final is just kinetics if we want to know the speed with which the elephant hits the water when it falls all the way down through these 10 meters of height. So 2 times gh is going to be 2 times 10 times 10, 200 plus v initial was 5, so that's 25. So you have square root of 225, which is 15 meters per second. So if that elephant gets a jump, gets initial kinetic energy, the speed is 5 meters per second, regardless in which direction he jumps, and then the elephant is 10 meters above the water, you just work with this formula, cancel masses, and you end up with the final speed. Now, a little more complicated, let's say that we want to know his speed when the elephant falls down halfway. Now, the jump to a conclusion that you might make is if the elephant falls through half the distance, maybe he will gain or lose half the speed or something like that. Half and half here does not really work out because kinetic energy it has velocity squared. So if you remember in the previous example, we had 10 meters per second as the full speed. So why wouldn't it be 5? It wouldn't, because velocity is squared. So don't jump to conclusions, but rather work with formulas the whole way. So mechanical energy initial equals mechanical energy final. Oopsie, sorry about that. So in the beginning, we have potential energy plus kinetic. And in the end, we also have potential plus kinetic. And we can cancel mass. And what I'm doing, I'm rearranging, I'm taking this part, there must be a plus in here. We're taking this part and putting it to the left. So I'm going to have mgh initial minus mgh final. Since it's multiplied by mg in both cases, I can just do mg initial minus final h. And then since we cancel mass, it's just going to be 2g, and 2 comes from multiplying everything by 2, so I can get rid of the denominator. So v final equals, get rid of 2, get rid of mass, we end up with g times h initial minus final, because this goes over here with a minus, plus what's left over, v initial squared. So 2g is 20, height initial was 10, height final is 5, so that's going to be 20 times 5 plus 25. It's going to be 11 meters per second. Notice that it's not 5 plus 5, 10 meters per second. It's 11 meters per second, because math-wise, that's what it amounts to. 125, when you square root that, you get 11. Well, technically it's like 11.2, because you know that 11 squared is 121, but close enough with 2 sig figs. Another example will involve sliding down an incline. No, actually, here's another example. Let's say we start with just kinetic energy. So a soccer ball is kicked straight up with 5 meters per second, and we need to find out how high it will rise actually above the ground. So what's the height? Mechanical energy initial equals mechanical energy final. In the beginning, the ball has kinetic energy. In the end, it has potential energy. Cancel masses, and you end up with H being V initial squared over 2G, which is 25 over 20, gives us 1.25 meters. Another example, let's say we want to find how fast the ball is moving once it rises by 0.5 meters, so to a height of 0.5 meters. So mechanical energy equals initial equals mechanical energy final. In the beginning it's just kinetic, in the end it's kinetic and potential. So cancel masses, multiply by 2 to get rid of the denominator, and V final is going to be, I'm going to take this and put it to the left with a minus. Cancel masses, multiply by 2, we end up with V final squared equals V initial minus 2GH. So 25 minus 10 gives us 3.9 meters per second. Another example involves a block sliding down an incline. It's sort of like we could find net work done by forces, and then we could do mechanical energy, work kinetic energy theorem, but we can also use conservation of energy. If this plank doesn't have any friction, then mechanical energy is conserved. In the previous examples, we disregarded air resistance, and I should have said that in the beginning. But anyway, if there is absolutely no loss of energy in terms of friction, air resistance, any kind of external forces, then we can say that our energy is conserved. The only force working there is gravity. It's called a conservative force, because when gravity is the only force that is working, then all energy is conserved. It's just turning from kinetic to potential, or from potential to kinetic. So let's say we start this block at the top of a 5-meter incline, and we let it slide, and we give it a push of 1 meters per second velocity it acquires from our push. And we need to find out how fast it's moving by the time it gets all the way down to the bottom of the incline. Notice that L is not H. It's not the mgh. L is this hypotenuse, so we would need to find the height. So again, mechanical energy initial is potential because it's above the ground level. I'm going to say that this is the level where potential energy is 0. So mgh plus mv initial squared over 2 equals mv final squared over 2, because by the time it gets to the bottom of the incline, it won't have any potential energy left. Multiply by 2, divide by m to cancel, and you end up with V final squared equals 2GH plus V initial squared. Height, that's the leg that lies across from a 30-degree angle, so it equals half of the hypotenuse, because technically I would do 5 times sine of 30, and sine of 30 is half, so that gives us 2.5 meters. So from then, V final is going to be 2GH, so 20 times 2.5 plus 1, 7.14 meters per second. The next example is going to work in reverse. Let's say I want to know how high up the incline my block will slide if I give it initial push of 5 meters per second will be initial velocity, and the plank again is frictionless, so I know that energy will be conserved. So I say mechanical energy initial equals mechanical energy final. It starts with just kinetic, ends with just potential. So then cancel mass, multiply by 2, I end up with H final is going to, well, actually I don't need to multiply by 2 because I'm not looking for velocity, I'm just looking for H. So all I need to do is cancel mass and divide by G, and I end up with height final equals V initial squared over 2G. So V initial was 5, so that's 25 over 2G, which is 20, gives me 1.25 meters. Notice that 1.25 meters is the height. And the question is, how high up the plank will it rise? Then L is going to be, since it's the hypotenuse, I have to divide by sine of 30 because I know the opposite side. So then, since sine of 30 is half, when I divide by half, it's the same as multiplying by 2, and that's how I go from 1.25 to 2.5 meters. So that basically, hopefully, it will be helpful. basically explains how to handle potential energy gravitational and how to handle conservation of energy when potential turns into kinetic and kinetic turns into potential. Thank you for watching.